practice.
John holds bachelor's degrees in arts and in science from McMaster and Toronto, respectively, and master's and doctoral degrees in philosophy from the University of Toronto. To tell you more of someone you already know really well, John is a captivating lecturer and a clear and deep thinker. His talk today is entitled Relevance, Significance, and Religio. Welcome, John.
All right, so before I begin, I want to give some credit where credit is due. The talk that I'm going to give is based on some work I've done, paper I published with Tim Lillicrap and Blake Richards in 2012, paper I published with Leo Ferraro in 2013, current work with Leo, Anderson Todd, and Richard Wu, current work, a book I'm working on with Christopher Mastropietro, and some past work with Zachary Irving and Leo Ferraro on intelligence. Here's what I want to do today. And it looks pretty imposing, eh? 6 arguments, wow. So the first argument is I want to talk about the centrality of relevance. I know that's going to shock a lot of you, but I want to leap into this anyways. I want to talk about some of the necessary features of an account of relevance, and then argue that what we're really talking about is not relevance, but relevance realization, and why that distinction really matters. And then I want to talk about the bioeconomical embodied grounding of relevance realization. And up until now, it's like, what does this have to do with religion? And then what I want to talk about is the phenomenology of relevance realization and why that relates to what I'm going to call religio, which is a Latin word, and it's one of the contenders for the etymological root of religion. And I'm going to try and specify a somewhat technical use of it for the purposes of my talk. And then I want to talk about, finally, spirituality as the enhancement of relevance realization via the manipulation of religio. All right. So one of the things we're trying to do in cognitive science is try to understand what makes an intelligent cognitive agent. And so one of the things we can do when we do that is we can try and look at all the ways we try and talk about intelligence and test it, and one of those is problem solving. And one of the things that becomes clear is that understanding how a cognitive agent zeroes in on relevant information seems to be key to a lot of current dilemmas in psychology and cognitive science, dilemmas in problem solving, categorization, communication, and robotics. And a lot of these are, like I say, they sort of line up with some of our tests for whether or not something is an intelligent cognitive agent. So what are the issues involving problem solving and relevance? They break down, I think, into 3 core ones: search space models and combinatorial explosion, the real world nature of most problems. Most real problems are ill-defined problems, and fundamentally the need for insight, which should line up with some of the things that Colleen said earlier this morning, I think, rather nicely. Okay, what are the search space models? Well, this has to go with the work of Newell and Simon and the attempt to provide a formal analysis of what are the components in problem solving. And this has been a deeply influential model, not only within psychology and cognitive science, but economics, etc. So let me try and walk you through a version of this. Okay, so one of the things you do is you specify that you have a goal state. For example, it might be, I've had coffee, because apparently having coffee is a crucial thing, I just discovered. They bumped my talk. Like, you're not as important as coffee, John, deal with it. Okay, so yeah, that's your goal state, and then you have an initial state, I don't have coffee. Maybe that should have been red, I guess. And then what you can do is there's various actions you can perform, operations that will transform your initial state into some other states. And then in turn, from that, so forth and so on, until what you have, right, is a sequence of operations that will transform your initial state into the goal state. And then what a problem-solving method is a method for searching through this space of alternatives to find the pathway that will take you from the initial state to the goal state. Now, initially, this looks kind of like, and they became famous for this. This doesn't look like anything important. But good science often reveals the unfamiliar in powerfully counterintuitive ways. The problem with this diagram, right, is it misrepresents things because you have a bird's eye point of view. So you can see the pathway or the pathways that lead from the initial state to the goal state. But in real life, you're at the green dot, and you're looking out, and you don't know which of all the pathways are going to be the right one to take. And that turns out to be kind of problematic because those search spaces are often vast. In fact, that's not even a good enough word to capture it. So Keith Holyoake gave a good way of talking about this. The formula for calculating the size of the search space is f to the d. F is the number of operators and d is the number of steps. So take an average chess game. At any one turn, you have 30 legal moves, and there's an average of 60 turns. And so that's the search space, 30 to the power of 60. Or in standard scientific notation, 4.239 times 10 to the 88th. Now, you'd like to have that much money, right? That's a big number. That's a really big number. In fact, it's bigger than you think it's big. And I think it might even qualify for one of the things that Brian was talking about just a few minutes ago. In fact, I'm going to argue that later in the talk. Okay, let me show you how big it is, because we've been told a lot that our brains are really big. It's in the media all the time. Look at how complex the brain is. It's so complex, right? And you have sort of 10 to the 10 number of neurons in your brain, and that's a much, much smaller number. But it's not the number of neurons, it's the number of connections. That's right, 5 to 10 to the 14th. Still, much, much smaller number. In fact, 10 to the 82 is the approximate number of atoms in the universe. So the universe would even have a bit of a struggle searching through the search space. Okay, now what that brings out, and this is the counterintuitive thing, because you don't get it, right, in your experience. Somehow, you don't do that. You don't search. In fact, you don't search most of that huge space, most of the time, and yet you solve your problems in an intelligent manner. It sounds like a Zen koan. By ignoring most of the options and the information, you become rationally capable of solving your problems. It's cool, right? It's one of the most interesting things about you, this ability to just zero in on relevant information. Now, Newell and Simon tried to wrestle with this because they regarded this as one of their central things. They made a distinction, and this distinction has sort of slid around in its meaning a bit. But originally, when they talked about heuristics versus algorithms, the distinction was something like this. An algorithm was a problem-solving technique that was guaranteed to give you an answer, and that meant almost always that you had to search the whole of the space. And that means for very many problems, you can't be algorithmic because that would involve you in combinatorial explosion. Instead, they proposed what they called heuristics. And many people now put the two together, heuristic and bias, and we'll talk about that later. The heuristic, what a heuristic does is try to, out of that huge space, it tries to pre-specify what you should pay attention to, where you should focus your attention, how you should commit your resources. So for example, in chess, here are some heuristics. Control the center board, get your queen out early, right? Now you can do all of that and nevertheless still lose at chess, especially if your bias of looking at the center board affords your opponent the way of getting you to lose, right? Now, it turns out that I think while heuristics are an important part of the answer, in that sense necessary, they're not going to be sufficient, and that's going to be because you can't really deeply pre-specify relevance because there's no final definition of relevance. Instead, and this is what has come out in a lot of people's view, what was missing in the Newell and Simon work was the important role that problem formulation plays in constraining that space. So the way you represent the initial state and the goal state and your operators has a huge role in making it possible for you to solve these problems. Now, problem formulation is also related to another issue that's central in problem solving. This is the nature that many real-world problems are ill-defined. So a well-defined problem is when I have a clear and useful representation of the goal state, the initial state, and the set of operators. I take it for many of you, this is a well-defined problem. Right? You know what the initial state is. It's a multiplication problem. You know what the goal state is. Like, this shouldn't be a diagram of a platypus or a song. Right? And you know what kind of number it should be. And you know the operators you're allowed to perform. Right? And the things you're allowed to do. You get very, very good guidance from your representation of the initial state and the goal state and the operators as to what to do. The problem is, most real-world problems, contrary to what you were taught in elementary school, are not like that. Often the goal state is murky, the initial state is unclear, and the operators are unspecified. So I'm trying to give a good talk. That's my goal state. So how should I represent the goal state in a helpful manner? Give a good talk. Say good things. Say things that other people regard relevant or as important. What's the initial state? I don't have a good talk. What does that look like? Well, what are the operators? Say stuff. Okay? And think about how many of your problems are ill-defined. Following a conversation. You have to sort of, how much should I say? How much shouldn't I say? Getting a joke, summarizing a story, how close you should stand to somebody. Well, what do you mean? Well, it depends on a lot of things. Like, what's your relationship to the person? Well, I'm close to the person. I can always be close to them. No, you can't. You can be really physically intimate with somebody. You don't hang on them in a funeral. Oh, yeah, here I am with my, like, right? None of that, okay? I mean, my favorite one, and because of circumstances in my life, it's one I've had to re-enter and somewhat like it, is going on a first date with somebody. Successful first date. And it's an ill-defined problem because of the useless advice your friends give you. Like, pay attention to what they say, but not too much. Laugh at their jokes, but not too often. Ask some questions, but not too many. And and you figure out later that the whole point of the advice is that they can tell you later, I told you so. Okay. Now, what's crucial in ill-defined problems, what's missing from them, is problem formulation. Problem formulation supplies that missing relevant information. And what's really powerfully interesting about you, and what's been very difficult to give to computers, is how readily you take those ill-defined situations, supply the missing relevance, and turn them into well-defined problems that you can solve. It's really cool and powerful about you. I want to show you the power of problem formulation and also segue into the next topic, insight. So this is a classic problem. And many of you who have taken courses with me are groaning to see this. I promise I won't do the 9-dot problem. Okay, so this is from Kaplan and Simon from 1990, In Search of Insight. So this is known as the mutilated chessboard. So I have a chessboard, right? So it's 8 by 8. So how many little squares are there? 64. You should be able to do that. I'm teaching Spencer how to do that right now, my 10-year-old son. Okay, so let's say I have a domino, and a domino will cover 2 squares vertically or horizontally. How many dominoes do I need to cover the chessboard? 32, because 64 divided by 2. Okay, now I'm going to mutilate the chessboard, which sounds kind of like David Cronenberg, right? And I take out the 2 corner pieces. So how many little squares do I have left now on the mutilated chessboard? 62, right? Can I cover that mutilated chessboard with 31 dominoes and prove that your answer is correct? You have to be able to prove it. You've been in some of my lectures, so I'm not going to let you talk. Okay, so most of you are doing, and we know this because we've done this experiment several times, most of you have formulated this as a covering problem. And I can tell by the way you're staring at it. So what you're doing is you're trying to imagine 31 dominoes in various configurations on that mutilated chessboard to see if that will in fact work. That is a combinatorially explosive problem formulation. Famously, one of the students who had formulated the problem this way and was gifted in math filled 10 Hilroy notebooks trying to calculate it that way. And of course didn't succeed. Okay? Now, problem formulation, if you change from a problem formulation that isn't guiding you to one that is, right, notice what happens. So, let's change what we consider salient or relevant. Notice that if I put a domino on the chessboard, either vertically or horizontally, it has to cover always a black and a white square, correct? Yes? Which means, in order to cover the chessboard with the dominoes, I need an equal number of black and white squares. Take a look at the 2 corner pieces. What are they? White. So if I remove 2 whites, do I have an equal number of black and white squares left? But I must have an equal number of black and white squares, therefore it's impossible. What's going to freak you out right now is that many subjects in the experiment spontaneously came up with that. And now you feel inferior, right? Okay. Now that's plausibly what's going on in insight. What's going on is we formulated a problem one way, it blocks us from solving it, and we have to reformulate it in a way that affords us solving it. Now that tells us something very fundamental. What insight reveals about our relevance realization machinery, that it's inherently self-correcting and self-transcending. It's a dynamically self-organizing kind of phenomenon. What about categorization? That's another thing when we test people's intelligence. How well can you categorize things, right? And, it's supposed to be easy to explain categorization. They do it on Sesame Street. One of these things is not like the other. 3 of these things are kind of the same. And everybody, yeah, very good, well done. Right? And the problem is, and again, it's the obviousness of this that blinds us to the mystery, right? Because what's going on there is we have this assumption that what we do is we just look out and we notice that things are similar, and then we group them together and we keep the dissimilar things apart. And then what does similarity mean? Well, Sesame Street tells us. Similarity is kind of the same. Similarity is partial identity. Two things are similar, the more they're partially identical to each other. And what's wrong with that? Well, whenever things seem obvious, the thing you want to do is you want to bring in a philosopher. Right? And so I have one ready. His name is Nelson Goodman, which is a great name to have as a philosopher. Goodman, right? That's a great name. And he comes in and he says, well, look, the problem with that is that if you're strictly logical, any two objects are massively similar. Pick any two objects you want. So a plum and a lawnmower. Both weigh more than a paperclip, both have carbon in them, both didn't exist 300 million years ago, both are frequently found in North America, neither one makes a particularly good weapon. The list of properties that they share, those are all true, by the way. Nothing I said was false. The list of true properties they share is indefinitely large. Now, we know from the psychology what most people say, well, yeah, but those aren't the important. Those aren't the relevant features, which says that at the heart of categorization is not similarity, but out of the combinatorial explosive, technically logical set of partial identities, we zero in on a subset that we find relevant or important, and that constitutes similarity, and that constitutes our ability to categorize. Now, there have been attempts to try and get around this, to explain categorization, and trying to pre-specify what we find relevant through prototypicality, frequency, invariance, and simplicity. And all of these have suffered some very significant challenges in that they seem to ultimately presuppose the very relevance that I've tried to indicate to you. Communication. This is borne out from the fact that utterance is, by its very nature, incomplete because we're using general terms, and I'm trying to convey specific meanings to you, right? So what that means is I have to rely on you to draw implications and what Grice also called implicatures to fill in beyond what I'm saying. That's why you have to swear to tell the truth, the whole truth, and nothing but the truth, because there's always more, right, that has to be conveyed that can possibly be said. If I drive up and I roll down my window, we don't actually roll down our windows anymore, right? But people still do this on the highway, which is kind of weird, right? So my window goes down and I say to somebody, hey, I'm out of gas. Think about all that's going on there. Hey means somebody around here, pay attention to me if you hear this, but if you're only within your certain distance and judging your relative distance to the other people around you, I, which is who? The person just speaking, so pay attention to that. Out of gas, which isn't a request to be flatulent, right? I'm indicating that somehow I want the thing I'm in, my car, to be filled not with gas, but actually gasoline, and I'm hoping that because you're on the street that you have relevant knowledge about where gas stations might be, and so on and so forth. And what's going to freak you out is each one of those sentences I used to explain what was conveyed itself would need sentences to explain what is conveyed, and so on and so forth. And so what Grice did is he said, well, there must be ways of really constraining that process so we zero in on what we need to so that people get really good guidance on how to make these implications and implicatures. And he proposed 4 maxims: quantity, quality, manner, and there's the 4th one, relevance. And then what happened is that Sperber and Wilson came along and said, you know what? All of the other maxims collapse into relevance realization. For example, quantity is give the relevant amount of information. Manner is use the relevant format. Quality, which sometimes was originally proposed as tell the truth, actually means be sincere. That was what they argued. And sincerity means try to convey to me what's in your mind. Of course, not everything is in your mind, because that's overwhelming, but what's most important and relevant that's in your mind. So guess what? Communication collapses into the ability to realize relevance. Again, another one of the marks of intelligence, the ability to communicate. The next one, which is the most fun one, I guess, is the classic version of the frame problem posed by Dennett, also discussed by Fodor and Shanahan. And it has to do with the idea of real-world interaction. It goes like something like this. If you're going to be an actor, not a behavior, look, everything behaves. This behaves, generating effects. Right. But there's a difference between being a behavior and an actor or an agent. An agent, in some sense, has to deduce or detect the consequences of its own behavior and govern itself accordingly. So what we're going to do is we need to make a robot that can do minimally that, detect the consequences of its behavior and govern itself accordingly, and we'll put it into a really Darwinian primitive situation. It has to just find food, an energy source, and then take it to some area. And so here's the situation. You have this. I should have made a slide of this, right? So you have this robot. This is according to Dennett, right? And there's a wagon with a battery on it, and the robot deduces that if it pulls the wagon, it will have the intended effect of bringing the battery along, and that's the battery. Unfortunately for the robot, there's also a lit bomb on there. And an unintended side effect of the robot's behavior is that the bomb comes along and blows up. And then we think, oh, we're dumb. In order to make an intelligent cognitive agent, we have to have it look not only at the attended consequences of its behavior, but on unintended side effects. So we put the revised robot back into this situation. It goes up there and it's just calculating and calculating and calculating. And we're saying, what's going on? Well, the robot's doing what we told it to do, right? It's calculating all the potential side effects. So if it pulls the wagon, the left front wheel moves more than 10 degrees of arc. The right front wheel, more than 10 degrees of arc. The back wheel, et cetera, et cetera. There's going to be indentations in the grass, right? The air movement around the wagon is going to be slightly altered. The reflectance patterns are going to be changed. The position of the wagon with respect to Jupiter has been altered. Namely, the problem is that there's a proliferation of side effects. It's combinatorially explosive. And what we need in order to make even a basic actor is somehow an ability for, right, the robot to zero in on the relevant information. Now, Shanahan has recently, the person who's considered to have provided a logic for change and solved the technical version of the frame problem, said, once you get that logical aspect of the frame problem solved, what remains is this problem I've just laid out for you, what he calls the deep problem of relevance. Okay, so what I'm trying to show you is relevance realization is key. Now, you can sort of try and get candidate levels for relevance realization. What are we going to make it out of? What's it made out of, or what level are we going to try and situate its ontology if you want to be a little bit more philosophically precise? And there's sort of three standard ones. There's representation, computation, and modularity. The idea is the representational level is the level at which this is going to work. But that seems very problematic. This goes to an argument made by John Searle, who was recently invoked. And Searle points out that representation presupposes aspectuality. When I represent something, when I represent this as a bottle, I'm not representing all of its properties. I'm only representing a subset of all of its properties, and not in some unconnected fashion. I'm representing a subset of the properties and how they're relevant to each other and potentially relevant to me. That's what it is to represent this as a bottle. Okay? Now, what that means is representation presupposes aspectuality, and as I just showed in my description, picking up on an aspect is to pick up on a relevant subset, how those features are relevant to each other, and how they're potentially relevant to me. So at the core of representation is your ability to realize relevance, which means ultimately, although our representations can feed back and influence our relevance realization abilities, we ultimately cannot ground relevance realization in representation on pain of circularity. What about computation? Well, there's sort of two aspects to computation. One is encoding information into, abstract symbolic propositions, and then the second one is the manipulation by rules. And there's sort of arguments for each one of those. Fodor has one for the first, and Wittgenstein has one for the second. The point that Fodor makes is that if I have some abstract symbol, right, whatever your notation happens to be, let's A and B, it has a structure to it. He argues that relevance is not part of the structural properties of a proposition because it has to do with your cognitive commitment to the proposition, how much time, attention, and energy you give to it. And how much time, attention, and energy you give to a proposition is dependent on a whole host of unpredictable variables, and you can't try and pack all that variation into the structure of your proposition, or you're going to render it indefinitely ambiguous. So, another way of thinking about this is people judge how relevant something is independent, right, just of its structure, not completely independent, but they judge it in terms of how difficult it might be. This is the notion proposed by Christopher Cherniak and also psychological work done by Keith Stanovich. People tend to evaluate how important or relevant a proposition is in terms of the effort that they're going to have to put into it. This seems to be, in fact, importantly supported by some recent work on what's known as fluency in psychology. And some of the best theories of fluency, like Higgins' theory, his ROR theory, his relevance of a representation, basically say that what fluency is measuring is how relevant a representation is to someone. So, that's also borne out by the standard Kahneman and Tversky findings that people will treat logically identical information very, very differently. They will find logically identical pieces of information differentially relevant or salient to them. So that means you can't really pack relevance into the propositional structure. What about the rules applying to it? Well, this is an old argument. I think it actually goes back to Aristotle, but Wittgenstein gets credit for it. The idea is every rule requires an interpretation. Every rule requires how you specify its application. So if I have a rule, be kind, that means one thing if I'm being kind to my 10-year-old son, another if I'm being kind to a romantic partner, another if I'm being kind to a colleague, and it also depends on the situations. And you don't want to do this, right? You don't want to say, oh, rule, and then I need conditions of application. And then what you don't want to do is say, well, I'll have a rule for that. Because what are you going to get into? And this is Wittgenstein's point. You're going to get into an infinite regress. And what Brown argued in '88, and I haven't really seen any good overturning of it, is this has to ultimately terminate in something that's not rule-governed in an important sense. And he called this the skill of judgment. And you can make a very clear case, this is what I argued in my thesis, that the skill of judgment is just the ability to zero in on relevant information. All right. So, what about the idea that we have a special box in our head for doing relevance realization? I don't know, we might call it a central executive, the favorite homunculus of psychology, right? The idea that there's an area in our head that is specially designed to do this and we bust all the information there. The problem with that is it explains intelligence by having a little part of your brain that's intelligent, which doesn't explain anything. And also the little guy, the little part of your brain faces the very problem you're supposed to be solving. How does it know from all of the information in the rest of your brain what information to pay attention to, et cetera, et cetera? So these accounts are inherently homuncular and not helpful. Now, what does that tell us about some of the features we need for an account of relevance? Because of the collapse, I would say, of the computational, modular, and representational strategies, we know that in some sense, initially, relevance realization has to be a completely internal process. Initially, all the goals, initially, not finally, initially all the goals and criteria must be internal to the brain and emerge developmentally from within it. Relevance realization in this sense is necessarily a sub-semantic, sub-syntactic process, because we've just shown it falls below the level of representation and it falls below the level of computation. It has to be scale invariant. That's what the non-modularity. It has to be operating both locally and globally at all scales in a simultaneous manner. And it has to be self-organizing. It can't rely on intelligent design, right? Because that's a circular explanation. And it therefore must also be capable of self-transcendent self-correction in order to account for the phenomena of insight. That's a pretty tall order to solve all those, right? And when I wrote my thesis, I thought, I can't solve that. And I got really depressed. But I got the privilege of working with a lot of good people, Tim and Blake and other people, many of them protégés of Geoffrey Hinton. And we sort of, and some of the work I've done with, like I say, with Leo, we think that there might be a way of going on this. We think that the correct ontological level is the bioeconomical properties. And what do I mean by these? These are logistical properties, not logical properties. Logistics is about the rationing of resources, and that's exactly what relevance realization is. The logistical properties that operate on metabolic expenditure and optimization functions of obtaining reward that are initially internal to the biology of the organism. Now that's a mouthful, and I'm going to try and unpack that for you, okay? But in order to do that, I'm going to startle you first, at least I hope. I don't think there can be a scientific theory of relevance. And this is what caused me to despair in '97 when I was finished my thesis. I mean, everybody falls into despair when they finish their thesis. But, right, this was extra despair. And it goes something like this, right? Scientific inductive generalizations, which is the key machinery of science, require stable, homogeneous classes of intrinsic properties. And that's why there can't be a science of things that happen on Tuesdays. First of all, the set of events that happen on Tuesdays aren't stable in any way. Not the way, all the gold things are stably all the gold things. The class of events that happen on Tuesday is not homogeneous. There's nothing all those events share other than they happen on Tuesday. Right? Unlike, again, all the properties that all the gold things share. And Tuesdays aren't intrinsic to the world. Or it's even more freaky. Think about this. Saturdays aren't intrinsic to the world. It's not sort of here, right? Because the Egyptians don't have Tuesday or Saturday, right? Now, that doesn't mean that Tuesdays are made out of metaphysical goo or ectoplasmic something or other. It just means that, as Wittgenstein argued, we cut the world up in so many more ways other than science. Now, think about relevance. Think about all the things you find relevant, all the events you find relevant. Is that a stable class? No. Is it homogeneous? All the things you find relevant. Other than you finding them relevant, what do they share? Other things or events. Yes, okay. Other than that, nothing. Right? Is it intrinsic? Is relevance intrinsic to the world? No. I don't think there's anything a physicist or a chemist or a biologist can do to come in and say, oh, right, this has so much relevance. Okay. Now that might mean, oh my gosh, but I think it's actually a powerful help to get to this, because it makes you realize that maybe we had the wrong model. We were thinking that the brain was a relevance detector, and we should give that up. And there's an alternative way of thinking, and I want to try and get at that with you by proposing, right, that we can come up with a scientific theory of relevance realization. And I'm going to propose the strong analogy. The strong analogy is based on a similar kind of insight that Darwin came to, right? Consider the evolutionary concept of fitness. It's obviously not intrinsic to the physics or chemistry or biology of the creature. It's an inherently relational property. Great white shark, really fit? Yeah, drop it in the Sahara Desert. Dead. Okay? Okay? The class of creatures that are the class of creatures that are fit is not homogeneous. Some are big, some are small, some are fast, some are slow, some are hard, some are soft. Right? It goes on and on. Is it stable? No, that's the point of Darwin's theory. It's not stable. Right? So Darwin didn't try and come up with, right, the invariant definition of fitness. What did he come up with? He came up with a theory of how fitness is constantly, dynamically being reorganized, redesigned in terms of the constraints that are operating on a feedback process. So organisms are reproducing, and there's constraints on that constantly alter and shape the possibilities for design, and those previous instances of design constrain future instances, and design is constantly changing itself. And I want to propose to you that that's exactly what relevance realization is. Relevance realization is the way the brain, not in evolutionary terms, not in biological terms, but relevance realization is the way in which the brain is constantly evolving its fittedness to the environment. And that we can come up, therefore, with, right, a theory of that process of evolution that doesn't require us giving a final definition of relevance in any fashion. Now, the problem with the term self-organization, it's the magic epistemic wand that people wave over things to appear to give explanations or not. It's self-organizing, right? That's the sort of thing. I want to try and be more specific, and it's based on that point that I made earlier about heuristics. This is based on a couple of proofs, one of them called the no free lunch theorem, which tells you that academics need to get out more, right? Because that's supposed to be a joke. And it's the idea like this. See, this graph is supposed to represent performance on problems, and above the horizontal median means improvement. And the idea is, what a heuristic does is, for where the heuristic pre-specifies as relevance, matches the world, your performance is improved. And that's the left side of the graph. But you pay a price for it, right? It biases you so that where that pre-specification doesn't match the world, your performance actually degrades. That's why there's no free lunch. The price you pay for any heuristic is where the price you pay for where it succeeds is it actually makes your performance detrimental in other areas. But what can we do about that? Different domains have different heuristics have different domains of efficacy. And one of the things Tim and I realized is that nature has sort of a strategy for responding to this. It's kind of an opponent processing strategy. What you do is you find two heuristics that have complementary strengths and weaknesses, and then you have them dynamically and continuously competing with each other. And that way the system is constantly adjusting its ability to deal with the world. And that doesn't violate, by the way, the no free lunch theorem. Now what I want to propose to you is, just like evolution has, think about the evolutionary theory. You have selection. And I want to go into it right now, but I don't have time. I don't think selection is a cause. It's what Alicia Uraro calls a constraint. Causes are events that change actuality. Constraints are conditions that shape possibility. And I would say to Brian, I think one of the things we have to bring back into our ontology is this talk about constraints as opposed to just causes. Right? But you have selection, and it constrains, right, the process of reproduction, right, and inheritance. It reduces the options on design because it kills off things. But you also have an opposite constraint. You have variation, right? It's opening up the possibilities on design. And what you have is these two constraints opposing each other, one trying to reduce the options, the other opening it up, and in that feedback process, the animal's morphology is constantly being reshaped to its environment. I want to propose to you that similar kinds of things are happening in the brain. And there's increasing evidence, and I can't go into, there's lots of empirical evidence for both of these. The brain seems to be constrained to being as efficient as possible. It tries to get as much reward with as little metabolic effort as possible. And there's lots of theories in which this is becoming the central idea, right? Now, efficiency is one of those selective constraints. It reduces the options available to you. So what I'm proposing to you is your brain is this self-organizing feedback system, and there's a top-down constraint on it, reducing the options, namely efficiency. But there's also increasing evidence that the brain also has the opposing constraint. The brain also pursues a strategy of resiliency. It tries to keep its option open because it has to be able to deal with unexpected damage. It has to be able to rewire itself. It has to be able to adjust to sudden changes in the environment. And the idea I'm proposing to you, and that Tim and I proposed, and Blake and I, is that what you have is you've got this feedback process in the brain. You've got efficiency narrowing the options, right? Resiliency opening the options. And the fittedness of the brain to the environment is constantly evolving. Now, some of you have seen larger talks on this, and I can't go into it in great detail, but there seems to be a good way of showing that. The brain seems to be constantly oscillating between integrating its functions together, which makes it more efficient, and then breaking them apart to open up possibilities. This is known as self-organizing criticality in the brain. The brain is constantly doing this. In a scale-invariant manner, at all levels of analysis in the brain, you see this self-organizing criticality going on. And what's really cool is if that sort of evolutionary process is doing relevance realization, and if relevance realization is the central thing in intelligence, we should find a predictive relationship between self-organizing criticality and measures of general intelligence, and we have just recently found that, the work of Thatcher and others. Same thing with how the brain wires up, right? This is network theory. Brains can either be very efficient, or they can be very resilient, or they can find what are called small world networks that get a trade-off between resiliency and efficiency. And once again, you find the brain doing that at all scales of analysis. And recently what we have found is the more the brain wires up like a small world network, the better it is on measures of intelligence. So the brain is firing and wiring in a way that is implementing the proposed relevance realization machinery. And this lines up with, and we don't know of each other's work, we just recently came together, Marcus Breed's work showing that you optimize networks by getting them to trade off effectively between efficiency and resiliency. Those are his terms too, by the way. He came on those on his own. Like I said, we just sort of, oh wow, we're saying the same thing. Which can either be that you're on the track of the truth or you're both insane. So, now, what this means is something really, really powerful. Look, your bodies are not this Cartesian clay that you happen to drag around for who knows why. Right? What it means is your body is constitutive of you being a cognitive agent, of you having a mind. Right? It's the economy of your body that provides the constraints of efficiency and resiliency that make you a cognitive agent. That means relevance realization is not cold calculation. Relevance grabs your attention. It arouses your energy. It moves you. It causes affective states in you. Relevance realization is not only evolving, but involving. Look, I sort of project a salience landscape onto my world, and then I bind myself to it. And then I reproject from that bound, and then I bind myself to it. It's almost like breathing. It's this evolving process. And relevance realization isn't really, it also sort of transgresses on another Cartesian distinction. It's not really a property of the objective world, but that doesn't mean it's a subjective feature of our experience. I mean, if I have to coin a term, which is kind of, right, it's transjective. Relevance realization is inherently relational. It is co-created by the brain and the world being coupled together in the right way. So, relevance realization is how we are bound to the world, how experience is bound together, and how as we and individual and groups are bound together. That's why I had the binding at the beginning. Now, take a look at what relevance realization is. It's at least initially preconceptual because it falls below the level of concepts and categories. It's pre-logical because you need it in order to get your logical relations going. It's pre-experiential. If experience means meaningfully structured this, you need relevance realization to have meaningfully structured this. Relevance realization is pre-egoic. You emerge out of relevance realization as a cognitive agent. So do I. Relevance realization is pre-normative. All of your other norms, truth and beauty and justice, can't get a purchase on you until you're an agent in a meaningful world. Relevance realization is constitutive of being an intelligent agent in a meaningful world. In that sense, it's a meta-meaning affordance of particular forms of meaning. All the particular forms of meaning that we have depend on relevance realization. It's a meta-meaning affordance for all of the more particular forms of meaning we find. Now, I want to propose to you religio as a term for this fundamental binding that is constitutive of agency in a meaningful world. Religio is a Latin term. I didn't just make up a word, and it's not a typo, which everybody kept telling me. Your first slide has a typo. Your first slide has a typo. No. I'm trying to use this term, and I'm trying to build a new term out of it, but not in a motivated manner. Okay, religio is one of the terms that is proposed to be the etymological root of religion. The other is religare, which means to read back. And why religio is interesting is because it initially means to bind together. And so I'm trying to use this term religio because it has connections to the notion of religion, especially the central notion argued for by Clifford Geertz, the anthropologist, that what religion does, right? Religion is a meta-meaning system that fits the agent to the world and the world to the agent so that all the other meaning systems will work. So I'm trying to pick up on that, and I'm trying to pick up on the binding nature of what we're talking about here. So I'm using religio as a spiritual, I'll talk a little bit more about what I mean later, I'll try and discharge the quotations, a spiritual sense, as the sense of a pre-egoic to post-egoic binding. We're binding ourselves to a combinatorially explosive world with processes that are deeper than our egocentric selves. Right? As a sense of a pre-egoic to post-egoic binding that simultaneously grounds the self and its world. And what I want to point out is that this process is inherently mysterious, but I want to be precise about what we mean by the word mystery. I want to treat the word properly, but I don't want to give it more than its due either. I take the notion of mystery from Gabriel Marcel's essay on it, and he says, look, a mystery is different from a problem. By the way, mystery novels are not mystery novels. They're problem novels because they're solved. Okay? So a mystery is you have a problem and you frame it. Remember, they're like the robot, you're trying to put a frame around your cognition, and then you do something. You find that the frame is preventing you from solving the problem. Remember the mutilated chessboard? And so you step back and look at that frame from a more encompassing frame. And this ability to step back and look at your framing is important to insight. You do this, and then you realize, oh crap, that's also problematic. And then, oh no. Right? So I would sometimes freak out my kids. I'd sneak into their bedroom and I would write on their whiteboard, "Does time take time to happen?" And then I'd leave. Okay. The point is, you cannot, that framing process of relevance realization, you can never comprehensively bring it into, right, the frame. You can never completely objectify it. It can never be a completed object of your awareness. Because whenever I try and look at my framing, I make it something framed, and then there's a more encompassing framing that is not in view. And you can't jump back over that shadow. There's something inherently mysterious about it. You can never fully comprehend it. And then the weird thing is you realize this I, if we use the word to point to that, reframing, that you can't fully grasp, is coupled to a world that is combinatorially explosive, which means you can never fully grasp it. There's something inherently mysterious, phenomenologically mysterious about both poles of the relevance realization machinery. But we have to be careful. Phenomenological mystery is not identical to either theoretical inexplicability or metaphysical necessity. It can lead to those, but it's not identical to them. We have to be careful. Look, my own death is phenomenologically mysterious to me. I can't put myself into the position. What's it like to be dead? Because no matter what I do, I'm alive, experiencing that state. But that doesn't mean, hey, I just proved I'm immortal. Or it's necessary that I can't die. So you have to be careful not to slide from one into the other. So Paulo Costa, in his article, The Secular Wonder, points to the very important realization. This is a quote. "The very ordinary fact that things always matter in some way or other to us, and that we cannot help but be affected by things as if we are immersed in a sort of bubble of meaningfulness, or better, in an atmosphere of significance, to use Brian's term, and import that we do not create from scratch but are absorbed by." That was my point about it being egoic in nature. "The metaphor of atmosphere should suggest not only the image of global container, but also that of a rhythm of breathing, as I mentioned earlier, and of a light refraction which a living being must attune or adjust herself. He then goes on to point out there's a central consequence of what he calls a bubble of significance. The experience of having a world has its roots not in a head-on and focused relationship with a clear-cut object, but in the emergence of a bubble of significance that for a sentient being plays the same role that is played by the atmosphere with regard to the earth. It creates, that is, special conditions of life, or I would say special conditions of mind and cognitive agency, where existentially crucial distinctions between inside and outside are drawn." He then goes on to argue that the atmospheric nature of the bubble of significance means that we don't experience it as a focal object, the way you can focus on the bottle, or me, hopefully, right? Instead, we experience this through non-focal states, such as wonder and awe. I would add, also they're opposites. We experience it negatively through non-focal states of absurdity and horror. And most horror movies aren't horror. Most horror movies are startle and puncture movies. It's like, ah, and something stabs you, right? Horror is the sense that your grip on reality is slipping. So I have a proposal for you. Human spirituality, as opposed to full-blown religion, is about preserving and enhancing, making it more adaptively insightful, the relevance realization machinery at a fundamental level. And this is done by manipulating the sense of religio. And the result is not knowledge and explanation. The result is wisdom, compassion, an alteration in what we care about, the kinds of insights we're capable of, the way we can change what we find salient and redirect ourselves accordingly. And this process cannot be fully expressed by statements of belief, because relevance realization is sub-semantic and sub-syntactic. It is experienced non-focally, mysteriously, and because there can be no final definition of relevance. Yet none of this licenses, I believe, a supernaturalistic metaphysics. Brian and I can argue later about what metaphysics it might license. I look forward to that. I have a specific proposal of this. Mindfulness practices and enhanced insight and self-regulation, which are core components of wisdom. So this is some of the work I do on mindfulness. And that we find many practices, as Colleen said, that in which there's alteration of consciousness at the core of religious or spiritual practices. We already have a lot of good experimental evidence that putting people into a state of mindfulness, like in meditation or contemplation, enhances their capacity for solving insight problems. There's a list. The Moore and Malinowski is important because what we're able to show is, in fact, the reduction of the Stroop effect. This is the Stroop effect. What you have to do is quickly say the color of the ink. Go. See the interference? Notice that Marshall McLuhan would love this. There's a conflict between the medium of the representation and the message, right? And you have to redirect your attention to the medium rather than to the referential message, okay? Now that, many people talk about that, Apter and Metzinger and others, that's a transparency opacity shift. Let me show you what I mean. Normally my glasses are transparent to me. I'm looking through them, beyond them, and by means of them. Sometimes, though, I get gunk on my glasses, and what I have to do is, instead of looking through them, I have to stand back and look at them. Remember this? Right? So my glasses are now opaque to me. And the interesting thing is you can do that also with respect to your mind and your framing of the world. Normally you're looking through it, but in meditation you can practice stepping back and looking at it. Being present, therefore, involves being less representational by doing that, by doing a transparency opacity shift. So you're no longer in a representational manner reaching out to the world because you're focusing your attention on the representational medium. So when you're meditating, you're following the sensations being generated by your breath. Normally you follow the world through your sensations, but in meditation you follow your sensations. Being present also involves breaking up chunks. You take most of your experience is organized into chunks, pieces of information, and how they're relevant to each other. We talked about that. But in meditation, you pull it apart. You look at all the individual sensations. You break up those chunks. And that reduces the capacity for you to engage in inferential processing. Now, it turns out, independent of the mindfulness literature, insight, the psychological work on insight was coming to exactly the same conclusions. You can enhance insight by breaking up chunks and de-automatizing your processing. When I step back and look at my processing, that tends to de-automatize it because I become aware of it and I can intervene in it, right? And insight is increased by doing transparency opacity shifts, by stepping back and looking at how you're framing a problem rather than automatically looking through the frame. So Knoblich and Associates gave some evidence for chunk decomposition and constraint relaxation driving insight. And DeYoung, Flanders, and Peterson, I don't think Jordan's here today, also did similar work with frame breaking. So this is the Knoblich stuff. You take a look at the top problem. You have to move one matchstick to change it from being false to true. And most people find this hard because they don't realize that they can break up the equal sign, because that's a really tight automatic chunk for them. But the more people can break up chunks, the more insightful they are. And notice that also requires you have to de-automatize your cognition. Here's what Jordan did with the frame breaking experiment. You give people, it's called an anomalous card task. So you're flashing cards up on the screen and people have to say, oh, that card's wrong. That card's wrong. What's wrong with those cards, by the way? Those are hearts. What color should they be? Red. Okay? So what you have to do in order to solve this problem is you have to break up the automatic framing. You have to look at your framing rather than looking through it. And you have to break up the chunk into one of its features, the color. The better people are at doing this, the more insightful they are. What I'm saying to you is the way meditation dissolves, right, your cognition into the medium by doing transparency opacity shifts and breaking up the chunk is the same processes that enhance insight. We have evidence for it going the opposite way. Baker, Sennett, and Ceci, how what they called cognitive leaping is predictive of insight. Here, I'll show you an instance of it. So, what is that? Whoa. So the people that answered are good cognitive leapers. They go from very few cues to the correct answer. And they get to go on the alien ship when the alien ship comes to take us to heaven. Okay. So what you can do is you can control this experimentally and see how much it takes. Now notice you go in the opposite direction here. Notice you're going from features up to a gestalt, And you're going from looking at it to looking through it as a representation. Do you see that? So going the opposite way also is predictive of insight. There's supplementary work showing this on picture reconstruction, the control level theory. I don't have time to go into it. Right? Similar work also with self-regulation. Self-regulation requires being able to dissolve things down in order to delay gratification. It also requires you expanding your frame up in order to know when you should delay gratification. So self-regulation also, like insight, requires the ability to scale attention down and scale attention up. And what I want to propose to you is, for example, in Buddhism, you see both of these being trained together in a comprehensive praxis. You have the Eightfold Path, which is a wheel, which is a nice representation of a dynamical system, by the way. And the right there isn't moral rightness. It's like the right-handedness. It's dexterity. It's the ability to be well-fitted to the environment. It's a relevance realization thing. And so you have right concentration and right mindfulness, which, by the way, implies there's wrong concentration and wrong mindfulness, something people in the West need to pay a little bit more attention to, right? But in addition to right meditation, dissolving down and inward, there's right contemplation, there's right understanding, and that's trained by practices in which you go the other way, like metta, in which you extend your sense of identity involvement outward. So you practice these two things together, scaling down and scaling up, and you practice them comprehensively together. And you would be optimizing a person for insight and self-regulation by doing that, by altering their state of consciousness, altering the religio, altering what they find relevant, altering their salience landscape, teaching them these skills. And what is supposed to result from that is a deep kind of insight, vipassana, which means insight, or kensho, a deep kind of re-realization of what matters, what's important. The Buddha said, look, the ocean has one taste throughout, salt. All of my teaching has one thing, freedom. He was not ultimately about what's the ultimate metaphysics of things. It's about trying to get people the insight and the self-regulation, the wisdom and compassion, the ability to alter what they care about, what's salient to them, so that they could live more flourishing lives. It's about wisdom, not primarily about knowledge. And that distinction matters. It's an important distinction that we've lost, we've got to bring back. So what have I said? Relevance realization is central to human intelligence, experience, and agency. The phenomenology of relevance realization, or what I'm calling religio, has many features traditionally associated with human spirituality. Human spirituality is not primarily about belief, but about practices that enhance relevance realization by manipulating religio, as in spiritual paths this was a particular case example, as in spiritual paths that integrate meditative and contemplative practices so as to enhance insight and self-regulation in an integrated manner. And so what I'm proposing to you is that there's a deep connection between some of the central projects going on in cognitive science and some of the deep practices that we find going on in human spirituality. Thank you very much.